Hi students, this is Mr. Yao. This lesson is going to start a new unit, which is coordinate geometry. And we're going to learn more about linear equations. First, we're going to learn a new form in this lesson, which is called point-slope form. But before that, we are going to review what we have learned about linear equations. Prior knowledge. A. Write the slope-intercept form of the equation of the line that passes through the point 0, -2 and has a slope of 2/5. So, if the point is 0, -2, which is right here. Well, that basically means that's my y-intercept. So b is -2. And if the slope is 2/5, my equation is going to be y equals 2/5 x minus 2. So I can graph it. -2 is the y-intercept, up 2 over 5, up 2 over 5, or down 2 over 5, and down 2 over 5. So there's my equation. There's my line. There you go. Rewrite 3x plus 4y equals 8 into slope-intercept form and graph the equation on the same graph. So in order to rewrite it, the slope-intercept form is y equals mx plus b. So in other words, for this, we're solving for y. Subtract 3x on both sides. We got 4y equals -3x plus 8. Then we divide everything by a 4. So y equals -3/4 x plus 2. Let's graph it. Y-intercept is going to be a 2, but this time the slope is a -3 over 4. So down 3 over 4, down 3 over 4, or up 3, left 4, and up 3, left 4. There you go. And I can graph my line just like that. That's B. Moving on. To write or graph a linear equation, we will always need two things, a point and a slope. And that's exactly what we have been doing. And in that case, if it's slope-intercept form y equals mx plus b, we actually have the y-intercept as the point, which makes it easier to write the equation. But what if the point given is not the y-intercept? Then suddenly we don't have this b anymore, so we need something else. We can find the y-intercept by remembering that if a point is on the graph, then it works in the equation as well. Let's see how that works in some examples. Example 1. The point is -5, 2, and the slope is 3/5. So we know that we want slope-intercept form, so we know we need y equals mx plus b, and more specifically, the slope is 3/5. So that is going to be what the equation looks like. Right now, we just don't know what b is, but we can actually solve for b since we are given an extra point. This point is going to work for this equation, which means we can actually now plug in x for -5, so it's 3/5. Now the x is going to become a -5, but we still have the plus b, but on the other side, the y is a 2. So I'm just putting the point into the equation already. And now you can see we have an equation that is just missing b, so we can actually solve for b. Who is on the left side? 3/5 times -5 is a -3 plus b. Add add 3 on both sides. So my b is a 5, which means my equation is 3/5 x plus 5. That's example 1. Let's try example 2. Y equals, my m is a 0 times x, then plus b. Well, let's actually still plug the points in. So 6 for y, 6 for y, and -4 for x. So 0 times -4 plus b. Well, anything times 0 is a 0, which means b equals 6. So my equation is 0x plus 6, which is just y equals 6. That's example 2. Now please pause here and try example 3. Let's have a look. Same idea. Y equals, my slope is a 4x plus b. And then I'm going to plug in the y, plug in the x. So I have -9 equals 4 times -2 plus b. So it is -9 equals -8 plus b. Then we can add an 8 on both sides. So my b is going to be a -1, which means my equation is y equals 4x minus 1. That's example 3. What if we don't even have to find the y-intercept? Because previously we were still actually using the y equals mx plus b, use the point, and then actually try to find the y-intercept so that we can write the slope-intercept form. Besides the slope-intercept form, we have also learned the slope formula, which is m equals y minus y1 over x minus x1. More specifically, we learned it slightly differently. We learned y2 minus y1 over x2 minus x1, especially when we are given 2 points, x1, y1, and x2, y2. That's typically how we label the 2 points. Then we can use the 2 points to find the slope. We can actually multiply both sides by x minus x1. So if we actually do that, the left side, well, the right side, when you multiply with an x minus x1, that's just going to cancel out the denominator. On the left side, that's actually going to stay. So now we actually have something called a point slope form, which is y minus y1 equals m times x minus x1. M is the slope, and the x1, y1 is actually a point. That's why it's called a point slope form. Because we just need a point and a slope. Doesn't matter what the point is, then we can actually write point slope form. So let's see, example 4. We are going to write into point slope form, and then we're going to convert it into other forms. So we are given the slope. Let me write the point slope form on the top. It will actually look like y minus y1 equals m times x minus x1. Y minus y1, y stays minus. My y1 is a 6. So whatever point that is given is going to be a x1, y1. So y minus 6 on the right side, my slope is a negative 1/2, and then it's going to be x. My x1 is a negative 2, so it's x minus negative 2, which is actually going to be x plus 2. And that is a form. We don't have to do anything else. That is the point slope form. But next thing, it does ask you to actually simplify it or transform it or convert it into a slope-intercept form. Slope-intercept form is y equals mx plus b, so our goal is to get y by itself, which means we are going to add 6 on both sides, which is going to give us y equals negative 1/2 times x plus 2, then plus 6. But we can't keep it like that. Inside the slope-intercept form, we don't have parentheses, so we're going to need to actually distribute and get rid of the parentheses. Y equals distribute negative 1/2 x minus 1 plus 6 simplifies to be y equals negative 1/2 x plus 5. That's example 4. Please pause here and try example 5. Hopefully you have tried. The point given is going to be x1, y1, so we can write the point slope form. Y equals, no, not y equals, y minus a negative 9, because that is currently my y1. On the right side is the slope. And then x minus my x1 is a negative 10. But we can't have double negative. That's going to be simplified to be y plus 9 equals 4/5 times x plus 10. There you go. That's the point slope form. Now, in order to get the slope-intercept form, we're going to need to get y by itself. So subtract 9 on both sides. Y equals 4/5 parentheses x plus 10. Copy everything down with a minus 9 on the end. Then the next step, of course, we're going to need to distribute to simplify. Y equals 4/5 x. 4/5 times the 10 is a plus 8 minus 9. Lastly, simplify to be y equals 4/5 x minus 1. And that is the slope-intercept form. Moving on, example 6. 6 and 7, now things are a little bit different because we are not given the slope directly. We're given 2 points. But we still want to write into point slope form. Y minus y1 equals m times x minus x1. In order to write this point slope form, we are going to need to find the slope. As for the points, we can actually use either one. So let's actually write, let's say this is my first point, x1, y1, and this is my second point, x2, y2. In order to find the slope, we always do y2 minus y1 over x2 minus x1, which is going to be 5 minus 8 on the top. That's my y2 minus y1. As for the bottom, x2 minus x1, don't forget to keep the negative. It's subtracting a negative 4. So I actually get a 3 on the top. 2, the bottom becomes a 2 plus 4, which is a 6. And that simplifies to be a 1/2. So now we have a slope, and we also have 2 points to choose. You can actually use either point. Let's say we want to use the first point. If you want to use the negative 4, 8 to actually write a point slope form, that's going to be y minus 8 equals 1/2, then times the x minus negative 4, which is actually going to become x plus 4. That's if you use negative 4, 8. Let's say you want to use 2, 5, y minus 5 equals 1/2 times, and it's going to be x minus 2. That's example 6. Now you can pause here and try with example 7. First thing, of course, we're going to need to find the slope. M equals x1, y1, x2, y2. Oh, previously you might be wondering, wait, how come like you have labeled as x1, y1 for negative 4 and 8, but 2, 5 is actually x2, y2? How come you actually use that to write a point slope form? It doesn't quite matter. This y1, x1 is just a subscript indicating that they come from the same point. It could be x1, y1, x2, y2, x3, y3, whatever, however you want to label them. So now m equals y2 minus y1 is a negative 1 minus 2 over my x2 is a negative 8, my x1 is a negative 4, so minus a negative 4. The top is a negative 1 minus 2, which is a negative 3. And the bottom is a negative 8 plus a 4, which is a negative 4. simplifies to be 3/4. Now I have the slope, which is 3/4. The 2 points I can use, one of them is -4, 2. If you want to use that to write, it's going to be y minus a 2 equals 3/4 times the x part is an x minus -4, so that's x plus 4. If you want to choose -8, -1 to write, is going to be y. This y minus -1 becomes y plus 1. On the right side, 3/4. And it's going to be x minus -8, which becomes x plus 8. And they are both going to work. They're both point slope form. You might be wondering, how come we have different point slope form? How come that works? You will see how it works in example 8 and example 9. So let's move on to example 8 and 9. This time you're given 2 points. It's asking to find the point slope form, and then it's also asking to write into slope-intercept form. So let's have a look. First, of course, we're going to need to find the slope. -7, let's label them. You can always label them if that makes things clearer for you. So y2 minus y1 is -7 minus a -9 over x2 minus x1 is a -1 minus 3, which is going to be on the top -7 becomes a -7 plus 9, and that is a 2. On the bottom, -1 minus 3 is a -4. The whole thing simplifies to be a -1/2. Same thing. Let's say you want to use either points to write. Let's say you want to use 3, -9 to write. That is going to be y plus 9 because of the y minus -9, and the slope is -1/2. X is x minus 3. That's if you use 3, -9 to write. Or you can use -1, -7 to write. So y, that's y minus -7, which is y plus 7. On the right side is the slope is -1/2, and it's going to be x minus -1, which is x plus 1. Okay, I chose to write both because now I want to show you what is going to happen when you try to change them into slope-intercept form. Let's say the first one, I need to subtract 9 to the other side. We're going to get y equals -1/2 times x minus 3, then a minus 9, which is y equals -1/2 x. -1/2 times a -3, don't forget to distribute, is a positive 3/2, and then minus 9. Simplifies to be -1/2 x, positive 3/2 minus 9, which is like minus 18 over 2. So it's actually a minus 15 over 2. That is if you use the first point. That's if you use 3, -9 to rewrite into point slope form and then change into slope-intercept. Now let's see, what if we actually use the -1, -7. So I need to subtract 7 on both sides. That's going to give us y equals -1/2 times x plus 1, then minus 7, which is y equals -1/2 x. -1 times a 1, and -1/2 times a 1 is a -1/2, then minus 7. So minus 7 is the same as minus 14 over 2. So it's -1/2 minus 14 over 2. We're going to get y equals -1/2 x minus 15 over 2. There you go. Now you can see, doesn't matter which point you use, the slope-intercept form is exactly the same. The reason is both points are on the same line. So they are going to get the same equation since, they have the same slope. They're just at different positions on the line. So when you write point slope form, they may look different, but they're actually exactly the same. Now you can pause here and try example 9. Same thing. Let's find the slope first. 10 minus -9 on the top. 9 minus 4 on the bottom. So we got a 10 plus 9, which is a 19 on the top. And the bottom is a 5. You can choose to use either point to write a point slope form. I'm just going to take the second point as an example. Y minus 10. The reason is just the second point, they're both positive numbers. So it's easier to write. I don't have to think about the subtracting negative. 19 over 5 times x minus 9. Now in order to change into slope-intercept, I'm going to add 10 on both sides. So we are going to get y equals 19 over 5 times x minus 9 plus 10. So y equals 19 over 5x. Distribute. 19 over 5 times a -9 is going to be a minus 171 over 5, then plus a 10. Of course, you can put that into your calculator, or the plus 10 is the same as a plus 50 over 5. So it's a -171 plus 50. So y equals 19 over 5x. Then it's going to be a minus, so it's -171 plus 50, so it's -121 over 5. And that is example 9. That is everything for this lesson. Thank you.